Hi, I'm Callie Stroskop, and I am a Site Reliability Engineer at HashiCorp IBM. In this video, we are going to continue working on the Deploy in Public workshop. We're going to do challenge number 6, where we deploy a CRUD API that persists its data into an AWS RDS database. Pretty cool, right? If you haven't done challenges 1 through 5, I recommend backing on up and giving those a try first because the challenges build on one another. We're actually going to use a lot of the same Terraform code in this challenge that we made in previous ones. With the CRUD API and the RDS database, we're going to be using Terraform to deploy the infrastructure. So that way it's all automated. And we're going to use GitHub Actions. So that way, anytime we want to push new changes to our code or even a database migration, everything deploys automatically. If that sounds fun, keep watching. If that doesn't sound fun, what is fun to you? Just kidding. All right, thanks for watching. You should have an API with, data source added, an empty migrations folder, a to-dos module, because we're going to just build a simple to-do list to deploy. And you should also see that your app module folder has changed a little bit. We're now importing our to-dos module. We are importing some configs and the type ORM module that is right here. All right. Other than that, it's not really too different. We still will have the just get hello endpoint that we should be able to test. And then we will have a few more endpoints where we can use /to-dos to get all of the to-dos, add a to-do, edit a to-do, and delete a to-do. Okay. So just like normal, you would run npm run start dev. All right. And you should see some logs here where you can see that we are connected to our database, which is exciting. But if you open Postman, let's get Postman up and running. So I cleared my database out, so you'll see stuff here, but and I click send, you'll see that we get an error. Okay, so let's go look in our terminal to see what that error is about. And it's saying that the relation to do doesn't exist. All right, so the relation to do means that it's trying to get the to dos from the to do table, but it's saying we don't have a to do table, which fair, we don't. If you look in my env, you'll see that I have the information, and you'll have to add this to your env for my local setup, right? So my database host is going to be localhost. My username is my username, and my password is my password. All right. And then if you go to this data source right here, this is where you'll see where everything is getting injected. All right. We have logging true on because I want to be able to see what's going on. So it's trying this query where it's going to look for the to-dos in the to-do table. And then it's saying the query failed because the to-do table doesn't exist. Okay. And the reason why it doesn't exist, so next you'll see that the database, sorry, I'm getting to why it doesn't exist, but I'm trying to explain it in a good way. So the database that it's looking for is Postgres. Now, I use the database Postgres because it's going to allow us to skip a step in our deployment process. Because when you use Postgres, your database automatically has a database named Postgres in it. It's the default database. So that will allow us when we deploy a database to not have to worry about adding a new database. All right. So if you look under my coding with Callie, you can see that yes, we have this database Postgres, but if you go into tables, you can see that we do not have any tables. So of course it can't look up. So how do we get tables? Well, there's 2 ways to do this. The way most people in development do it is to turn this synchronized to true on. So what that means is it will go and look at your entities, which is NestJS's way of saying tables, basically, right? It's going to go look for any file that ends in entity.ts, and then it's going to make sure that that entity and all of the columns exist in your database. What's the issue with synchronized true? Well, in the development setting, nothing, because you want to be able to edit your tables, and it's nice that they automatically just edit. In production, though, oh goodness, you don't want to do that because you don't want to accidentally wipe user data. If you have a bunch of user data, let's say you have this website, it's been going for years and you decide, oh, that one column, I want to change the name of it, or I want to add a column, or I want to change a table, or whatever you want to do, and you have synchronized true on, you could wipe the data that you have. So we use migrations instead, okay? And migrations will run the SQL queries necessary to alter your table in production or your development environment, okay? So right now, in my migrations folder, I have nothing, but I have a command in the package JSON that will do this for you. So I'm going to go ahead and get out of my server, um, and I'm going to run it. So first thing that we need to do is generate the migration file. Okay, we have nothing in our migrations folder, so we don't have any instructions as to what our database needs to do to get up to speed. Okay, so the first thing we do is npm run migration : generate. All right. You can see here, this is basically saying we want to use the data source and we want to generate a migration, and then we want to put that migration at this path. All right. But I don't want to call it test. So you're going to have to change the ending to whatever you want to test. So I'm going to say add to-dos table. All right. And then save your file. And then now you can go over to here and click enter. And it's now looking and see how it says it looked at the current state of your table. It looked at what your table should be based on your entities, looked at that file, and then it generated a migration. All right. So if we go and look at that migration here, you will see that what it needs to do to get up to date is create a table to do. All right, and then here's all of the rest of the SQL commands associated with it. Okay, so that just generated this file with our migration in it. So what we need to do now is we actually need to run the migration. Okay, so we run npm run migration run. Click enter. And so now what it's going to do is it's going to go look in our migrations folder. It's going to see if there's a migration and it's going to find one, and then it's going to do it. You can see that it's actually creating that table, and then it's adding the migration into a migrations table. So let's go ahead and let's refresh our database. And now you can see we have a migrations table and we have a to-do table. Let's go look at our to-do table. And it has the ID, description, done, and created at column. All right, perfect. So technically I wasn't going to have created at column because I wanted to do that was supposed to be the end of the challenge where we added it and then ran the migration in production, but that's fine. We'll just leave it and we will add another column later in the process. All right, so now that we have that migrated, we should be able to npm run start dev. And yay, our database is connected successfully. So let's go ahead to Postman and let's just get our to-dos. And we see that we have an empty array, which makes sense because there's no to-dos in there. So let's change this to a post request. I'm going to post the to-dos and let's add a few to-dos. So let's say to-do 1. And now we have 1 to-do. Say to-do 2. Now we have 2 to-dos, and let's say to-do 3 just for fun. All right. So I automatically, by the way, I like to, when I have, let's go to our service. I like to respond, like if I add a new to-do, I like to return the whole list of to-dos. So I always just call find all at the end after I create, update, or delete. It's up to you on how you want to do it when you're developing, but that's why it's returning that. So now if I just go back to the Git route, I can see that I have my to-dos. If I just get rid of this to-dos at the end, I should see hello world attempting to deploy a change. Okay. So, and then you can see that I'm getting logs about all of this. You can turn the logs off if you want. I think it's helpful to have the logs on when I'm deploying though, to see like what my issue is, if it's with the database or my code or whatnot. All right. So that is what we need to do in order to deploy the steps that we just went through are also the steps that we need to go through in order to get our application ready to deploy. So now we need to figure out how we need to edit our Dockerfile, all right, in order to make this make sense, okay? So right now we are creating an app directory, we're copying over the package JSON, we're installing all dependencies, we're copying over the rest of our files, we're building our uh, application, we're exposing the port, and then we're starting our server. Okay, so that is all great, but it misses that step where we run the migration run command. So what we can do, and eventually we'll do this in a more elegant way, not in the Dockerfile, but what we're going to do right now is we are going to add the command to our command line here. Okay? So we can get rid of all of these quotes. And then basically we're going to be able to run both commands, the migration command and the start prod command, before we, like, all in the same line. So here we can just say npm run migration run and npm run start prod. And we can add that to our Dockerfile. So now our Dockerfile will build itself, all right, and then it will run migration run, okay, and then it will run start. So let's look at what it's doing when it runs migration run, all right. It's using typeorm, the package, to run the migration, and it's looking for the data source here. So let's go look at the data source. It's going to run the migration based off of this data source. So this data source defines that migrations are located, all right, in the folder that we're at, but up one, then in the folder migration, and then all of them that end in TS or JS, which is going to be all of the files in this migration folder, okay? So that is what this line is saying, all right? It's getting the current directory name that we're in, which we're in data source, okay? It's then going up one folder, all right, to source, all right? And then it's going into the migrations folder. That's what this part's doing. And then it's looking for anything with the extension of .ts or .js, which is right here, okay? So that's what it will do in the Dockerfile in this npm run migration run. And then it's going to start our server. All right. So I think it's nice to test your Dockerfile locally before you jump to deploying and testing it in the cloud. So that's what we're going to do now. All right, so the first thing that we need to do is we need to build our image, right? So Docker build -t, let's call this API, and then we'll say that it's in the current folder that we're in is where the Dockerfile is. All right, and it's gonna go ahead and build. I'm gonna pause until it's finished because sometimes it takes a while. All right, now our file is done building, so we can run it. All right, so we're going to use the Docker run command. All right, we'll go ahead and say that we want to, I don't actually want to remove it, but I am going to add the -d to run it in detached mode, so that way I can still use my terminal if I want. Then I'll just do -p to do the ports. So we're going to say port 3000, port 3000. I'm going to go ahead and stop my server because that's actually running on port 3000. So we might have issues with it. And then I am going to add environment variables. So this is something that we didn't need to do before because we didn't have any environment variables. But now we have three. We have host, username, and password. All right, so we need to inject that into our container in order for our container to run properly. All right, and the way that we do this with Docker is using the -e flag for environment variable. And then you just list them out. So you say db_host, all right, and then you can't use localhost because localhost within the Docker container would be itself. But if I want to do localhost of my machine that I'm running the Docker container on, what I can do is I can do host.docker.internal. And that is going to be my computer's local host. Okay. Then I want to add more. So I'm going to add another -e, and I'm going to define my next environment variable, db_username. And I'm going to set that equal to my username, which is Callie Stosecup. And then I'm going to do one more, db_password. And then we're going to set that equal to an empty string. And then I will go ahead and name my container API, just because that is what we do when we deploy. So this will give us a similar command if we want to reuse it. And then we want to use the container API. I'm going to go ahead and you can see that we got this ID number, so it is running. All right, so if I go ahead and do Docker ps-a, that's going to give me my container ID, right? That's my container ID up here. And it said it created 9 seconds ago and it's up, which is awesome. All right, so if we go bum, ba-dum, bum, bum, to Docker logs API, that's going to get our logs. And you can see that there's no migrations pending. And the reason why there's no migrations pending is because we're using our local database. All right. So if we're using our local database, then we have no issue. Like nothing needs to be changed, right? Because it's going to check the current status to the entity files. All of our entity files, we're already up to date. Okay. So the fact that it says no migrations are pending is great. Okay. So let's go to Postman, and it should be on localhost still. So I should be able to send, and right, perfect. I get hello world, attempt to deploy a change, and that's coming from our container because if you remember, we don't have this server running anymore, but we do have our container running on port 3000. All right. If this isn't clear, let's go ahead and say Docker stop API. All right, that's going to stop the API from running. And we're going to just change the run command so we use a different port. So that way we can be super clear that we are using our Docker container. All right, so all I have to do is go and change that first 3000. So basically you're saying that from the outside, you kind of read left to right. So you go left to right too. So let's change this to 5000, right? So on 5000, when I hit that, it's basically going to use the port 3000 within the container. All right. Oh, so Docker ps-a, we have that stop. So we have to say Docker rm API, which we did. So now we can go ahead and run it again. Oh, port 5000 is already in use. Which makes me wonder, what am I running on port 5000? But I'm not going to worry about it. Let's just do like 3015. Of course, Docker rm API. Let's try again. All right, there we go. Okay, so now let's do Docker ps-a. All right, so that's up. So if I go now and I send this, it's not going to work because there's nothing running on 3000. But if I go to 3015, it's also not going to work. Bleh. Is that what one I used? I did use 3015. Let's go to Docker and debug a little bit. So port 3000. So let's look at our Docker logs API. All right, I think I just didn't wait long enough. Let's try now. Perfect. Hello world. I didn't wait long enough. I was too impatient. All right, and then if I do /to-dos, I should be able to send and see my 3 to-dos. And why do I see 3 to-dos? Because my container is using my local database, and those are the 3 to-dos that I added before. All right, I also should be able to add a 4th to-do and post it. And now I can see all 4 to-dos. All right, so this shows you, right, in our logs too, we see that no migrations are pending. Then we see that it goes to run this node dist/main, right, file, which is our start prod command. You can see that it connects to the database successfully, and then you can see our normal logs that our routes are ready. So this is going to be the same process. We'll just view this on our virtual machines terminal instead of viewing it on our terminal in VS Code. All right, I went ahead and applied the infrastructure from last week. Well, the last few weeks, I guess. So we have VPC, we have 2 availability zones, we have 2 private instances, 1 in each availability zone, and we're using a load balancer and so on. All right, so this is all of the code. All right. Like we did in the other weeks, I think it's easiest to manually deploy something before you use Terraform. So we are going to first create our RDS, our relational database, using the console, and then we will go ahead and use Terraform. All right. So to create a relational database service, we are going to click the button Create Database. And it's loading. We can stick with standard create, that's fine. We're gonna go with PostgreSQL, and we can go with the default for engine version. All right, if you see here, we see multi-availability zone DB cluster. So the idea is of the multi-availability zone database cluster is that you will have a main database and then you will have a like kind of a backup read-only database. And the idea and a different availability zone. So this is supposed to be like making your application more available because if one availability zone goes down, then your secondary database becomes your primary database. This helps too when you need to do like take your database and upgrade the version or something like that. You don't want downtime. All right. So if we were actually doing this in production, we would have a right? Multi-availability zone database. All right, so here's the cluster. It creates a cluster with a primary database instance and two readable standby instances, each in different availability zone. Just the multi-availability zone instance creates a primary and then a database instance in a different availability zone. So, and then there's also just a single database instance, okay? RDS is pretty expensive. So since we're just learning how to do it right now, I'm actually going to have you click on the free tier option, and then you'll see that these options go away and we're just creating a single database instance. Now, if you were employed and your employer had tons of money and they were planning on having tons of customers for their application, I go ahead and do, production, and then you would probably want to do the multi-availability zone cluster. Um, but just for our purposes for learning where to go with the free tier, I don't really see too much of a benefit since of doing the more costly version when all we're doing is going to have a primary database instance. Like each one of those only has one primary database instance. The benefit of them is like the standby. We're not going to do any like different versionings of our database or like transferring data or anything like that. So the free tier is fine, is the moral of the story. Okay. So then we need to have a database identifier. So we can just say coding with Kali database is fine. I'm going to make things easy for this tutorial so that way you guys can see my secrets or whatever, is I'm just going to use Postgres as my username and my password. All right. So like they say here in credentials management, you can manage your password with AWS Secrets Manager, all right, which is a different AWS secret or AWS service. All right. Just because we are I try to only complicate things one at a time. We're already learning RDS. We're not going to go with secrets right now, but we will by the end of the workshop. Okay. So we're going to go with self-managed, and then we're just going to type in our password, which I'm going to make Postgres for both of mine. All right. So this is just going to tell you what like kind of size and configuration you want. I'm going to go with the small one. That's fine. Storage is fine. That's the minimum value, so we'll stick with it. All right, so now connectivity is kind of the next part that we're going to get into. All right, the most important piece of this is that public access needs to be no. All right, we don't want anyone to be able to touch this database. This is going to be similar to having a private instance within EC2, right, in a private subnet. Nothing can go in or out other than the connections that we allow. All right. So here is saying that we can connect an EC2 resource. All right, so what we can do is we can go ahead and connect our EC2 resource here, and then you'll see that it's going to put them both in the same VPC. Well, it's going to put the RDS database in the VPC, okay? Dun, 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 dun. All right. So now it wants us to choose a VPC security group to allow access to your database. Make sure that the security group rules allow the appropriate incoming traffic. So we can go ahead and do this where we will go with creating our own because we should be able to make it work. All right, so what we want to do is let's go to create new. And we'll call this like coding with Callie RDS security group. All right. And all right. EC21 to allow connectivity with your compute resource. I think I'm going to actually manually set it up later and play around with this. But I do need to set it in the same VPC. So we'll do that. I don't really want to create a new subnet. See we're creating a new subnet group. Yes, that's fine. Within this VPC, yeah, we do want that. All right, sorry, I'm just trying to think of like the best way to configure this. Okay, so create a new security group, availability zone. We're just gonna go with US East 1A. We don't need a proxy. All right. Password authentication is fine. I'm going to turn off performance insights. And you can see it's going to estimate your monthly cost. So it's going to be $15.44 if we kept this on the whole time. If we went and turn it to production, let's take a look at what that's going to be. See how we're up to 1,477. So RDS can get pretty crazy. So that's why we are using this. Okay, let's make sure I didn't mess anything up by doing that. All right, cool. So now we can create the database, and then just remember, after you create it, destroy it when you're done. That's $15 is over an entire month. So you shouldn't incur too many charges, if any, if you are closing out as soon as you go. All right, we'll close out of that. So it takes a while to create. So I'm going to go ahead and pause the video, and I'll come back in probably 20-ish minutes when this actually is done creating. So it's been about 10 minutes and we're still creating. So just wanted to check in. If yours is still creating, it's nothing to be super concerned about. It probably takes about 20 minutes total. All right. So our database has gone ahead and finished. So now it's saying it's backing up. So we'll let it go for a little bit longer, but let's go ahead and get started. All right. So what are we attempting to do? We are attempting to connect. Nope. Yep. All right. So we have our Dockerfile. All right. That builds our application, runs the migration, and starts the server. All right. When we created this using Docker, guess we use Docker in this one. All right. We use this command, docker run. So, and that's where we passed in our environment variables. So the first place that you would look to be like, well, how do I do this? Well, where did you use docker run last? And the answer to that is in this GitHub folder, GitHub workflows main.yaml. If you scroll down, you'll see that we have a docker run command here. All right. And we just don't have any environment variables that we're passing into it yet. All right. So what we need to do, all right, is we need to figure out how we can pass our environment variables into that docker run command. And we already seen here that we're using the -e and then putting it in. But in our terminal, we hard-coded what our things are. And here we're not. So instead, we're going to use vars and secrets to do it. So let's go back to our env. All right, and here we have it. All right, and now we need to figure out how we put those into our GitHub repo. So it looks like in my opinion, all of these will be secrets. Let me refresh this. Whoop, whoop, and our database is ready. So let's add a new secret. I'm going to say db underscore host. All right, and then we'll go to our database. We'll click on the database, and you're going to see this endpoint. Go ahead and copy that, and then you'll paste it in here as your secret and add secret. All right, next one, new secret, database, username. All right, and you'll remember that we did Postgres for both the username and the password to make that work. So new repository secret, db password will also be Postgres. All right, so now we have all of our secrets. All right, so now we need to edit the command. So what I'm going to do is, because I'm feeling lazy, is I am going to copy all of that. All right, and I'm going to go to my main, not main.ts, my main.yaml, which seems to be somewhere in the middle here. All right, I'm going to make this bigger. All right, and it looks like I did it right after port here, so we'll do it right after port as well. And so now we have database host is equal to, well, we don't want it to be the host of the container it's in, because that's not where our database is. We want it to be from the variable that's stored in the secrets in GitHub with database host. All right. Instead of database username, we want it to be the secrets that's in GitHub. And same with our password. All right. So now that command should work perfectly. All right. Now there's another step to the puzzle that we have here. All right. So if we take a look, we can see that we don't have any connected computed resources. Now this is going to be just ones that you specifically use this panel for. You can see that it'll say connections to compute resources that were manually created aren't shown. All right, so that's fine. Looks like we also have 2 security groups. Let's take a look at them. Select this. So you can see the inbound rules. So it looks like we're accepting traffic, port 5432. I'm not sure exactly what that's from. So that's a little bit confusing to me. But we can do custom. And then we're actually going to do the private security group. So we have to delete that, add rule. So the port that Postgres is on is 5432, and then we will do the private security group. And so the reason why we are doing this, at least I hope, is because this will allow inbound traffic from our private EC2 instances. All right, so we can go ahead and say save rules. All right, so let's go back to RDS. Let's refresh the page. Security group rules. All right, so EC2 security group inbound from that security group. Let's go ahead and click on it just to make sure. I know we just set it up, so it should be fine. I'm feeling a little bit paranoid. All right, yep, and the source is from the private security group. All right, so I don't know if it's going to work the first time, but let's go ahead and give it a try. All right, so we want to do git status, git add, git commit, added db, and we're edited workflow to deploy to RDS. All right, now git push, and this will set off our workflow. Let's go over here. Oh, you know what? I'm going to cancel the run because A, our build is disconnected, and B, I didn't change the instance IDs. So that's not gonna work. I knew I was forgetting a step. All right, so let's bring Terraform up again. Oh, apparently I didn't output my instance IDs there, so let's grab them here. And we want to go into our secrets and variables, find instance ID. I felt like I was forgetting something, and I was. All right, now let's go back to instances. Let's get the second instance ID. Nope. We don't want a new secret. We want to just go to instance 2 and update. Now let's try again. Get status. Commented back in the build job. All right, now we can push, and hopefully I didn't mess anything up by trying to cancel the builds, but we shall see. All right, well, this is kind of my favorite part, which is debugging. So, it's interesting because usually I feel like I see like a status is not this. But anywho, I am going to go into my EC2 instance 1. I'm going to connect via sessions manager, and I'm going to do some debugging. Now, I'm probably not going to get a lot because if I do Docker PS, you can see there's nothing there. If I do Docker PS /A, I'll see nothing there too. So that's not super helpful. All right. And the reason for this is because we have this --rm flag here. So anytime a container stops, it gets removed. So what's happening is the container, well, I'm not sure this is what is happening, but what I think is happening is the container is starting, it's trying to run the commands, it's not working. So then it's like, I gotta go. All right. So what I'm going to do is I'm going to remove the remove flag, and then I'm going to push my changes. That way we can hopefully view the Docker logs if that's what's happening, what I suspect. This just helps us debug a little bit more. So that's going to run through. It's going to have to rebuild, unfortunately, in order to rebuild with this command. Well, did I need to rebuild? I didn't need to rebuild because this command has nothing to do with the building of the image. It just has to do with the deployment job. But whatever, it's rebuilding. I will pause and I will resume in a moment. All right, so we're in the deploy stage. So we can open this up to see how we're going. We're sending the command right now. Oh, you know what? When I was confused about this, it's because in my personal one, I have this all in different steps, and so it actually helps me log a little bit better. But now you can see that because we are not removing the container when we stop, we can see the container now. So that means that we're successfully getting through the idea of pulling and running. It's just something's happening when we are running. So let's go ahead and take a look. So we're going to do Docker ps-a, and then what you can do and see, you can see exited 33 seconds ago. So it tried to start, it just couldn't. So I'm going to do Docker logs API, and we can see our logs. Oh, and here is the problem. All right. So error during migration run. Error, no pg_hba.conf entry for host, blah, 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 user Postgres, database Postgres, no encryption. Right. So I have this in the code, but I didn't explain it. So let's go back and look. So basically, what we need to do is here, I'm actually going to just highlight this and we will have Copilot explain it to us. Bum, ba-dum, bum, bum. All right, so this is the SSL field. And so all right, we're jumping too much for me to read while it types. SSL stands for Secure Sockets Layer Connection. So basically what we're looking at here is we're looking for this environment variable. And if it's equal to production, then we're saying SSL is true. All right. This means that the SSL will be used when the application is running in a production environment and not used otherwise. So when we are getting this PG HBA conf entry, it has to do with the this SSL property and the extra property. All right, we need to have the SSL certificate in order to be in order to connect to our database securely. All right. We don't have that though, which we would have to go ahead and set that up in a production setting. We're not going to go over that in this video. So this is kind of the workaround. But if you were at work at a company, this would be something that you wouldn't necessarily want the reject unauthorized to be false. But basically we're saying we're turning the SSL property onto true, and then we're not rejecting the unauthorized requests. All right. And it's not just saying unauthorized, whatever. It just means that unauthorized certificates will be rejected, which might be a security risk. And we don't have the certificate, so that's why we would have to register the certificate, and we don't have that. So that's why we're saying that we're not going to worry about rejecting it, because right now it's getting rejected and we need it to not be. All right. So we have to add an environment variable production to our main.yaml file. All right. So let's go here and we can say -e environment, and then let's just say production. All right. And let's do get status, get add, get commit, added environment variable, git push. All right, it's going to rebuild because I'm not turning that off. But while it's doing that, let's actually go look up this a little bit more, because I feel like it's still foggy as to why I'm getting that error. Hmm. All right. Let's take a look. All right. This looks like a good article. Mastering secure connections to PostgreSQL on Amazon RDS. All right. Fear not. This simply means that your Postgres instance is rejecting the connection. All right. So that's what we were thinking. And here's the detailed error. All right, so yeah, see, this is what we're saying. To encrypt your connection, download the certificate bundle from your AWS region. And then we were going to set this force SSL parameter. All right, looks like you can do a workaround. All right, so we're definitely doing a workaround right now, but hopefully it's a workaround that works. Also, we are likely about to run into an issue. Are we still building? Yeah. Yeah. Okay. So the issue that we're running into now here is, let's go Docker ps-a. We still have that. So we got that container. So we have to remove it. All right. And then we need to do that from, so now let's clear. So we removed the container that was on it. Right. We need to go to our second instance and do the same thing because we removed that --rm. And when we did that, it made it so when a container stops, it doesn't get removed, which is nice in the sense that we're able to see logs then, but it's not nice in the sense that um, if we try to start a container with the same name and we already have a container, that won't work. So anyways, I'm rerunning just the deploy to EC2 job. So we should be able to like kind of keep pinging Docker PS and hopefully see it at one point. Now I'm just being ridiculous. All right. So now let's do Docker logs API. All right, you can see the logs. If you want, what you can do is Docker logs API and then -f, which is going to follow. So you can see that there are no migrations pending. I'm wondering if that's because it did run the migration before in the, oh, I think it's because it ran the migration in the last one, but then when it went to start the container, maybe, I don't know. We'll have to see if it's working properly, but let's go ahead and then let's check this one. All right, and then let's do Docker logs API. All right, both of those are up and running. So we should be able to say curl localhost at port 3000. And yay, we get our hello world. All right, so now we know that our application is good, but we want to actually do curl localhost at port 3000 / to-dos. We get an empty array, which makes sense because this is a new database on the cloud. So now let's try curl localhost port 3000. Good. And then curl localhost at port 3000 / to-dos. All right, nice. So now let's go to our load balancer, which hopefully we just took enough time doing what we were doing that we have healthy targets, and we don't yet. So I'm going to just kind of hold off on that part. I'm going to copy the DNS name and get my Postman ready to go here. So we're going to paste in here. So that's our load balancer URL and then /to-dos. And then we're going to go ahead and say to-do 1. All right, let's check out our target group and see how we're doing. Still too unhealthy. So I'll go ahead and pause until those turn healthy. All right, now we have healthy targets. So let's go back to Postman and we should hopefully be able to send our request and whoop, whoop. We got that. So now let's add a few more to-dos. Yay. Woohoo, 3 to-dos. All right. And then let's go ahead and just copy this URL and put it in our browser. And this should be a GET request now. The first time you load your load balancer in the browser, remember it takes a while, but yay, we see all of our to-dos up there. All right, so now that we have manually created an RDS instance, we're going to switch over to using Terraform. So there's a few things that we need to do, like have Terraform provision for us. So let's go ahead and get started. So the first thing is the actual database instance, okay? So I'm just going to add it down here, but this would be a great exercise to also modularize your Terraform code a little bit more. We now have a lot of Terraform code, and the only module we have so far is the VPC. So there's definitely some work we could do. All right. Anywho, resource, and then we're going to say AWS DB instance. And we will call this Postgres. All right. So now we need to go ahead and fill it out. So I'm going to say allocated storage is equal to 10 is fine. All right. Engine is going to be Postgres. They're using MySQL, but that's okay. Let's go ahead and I'm not going to worry about engine version, but let's do instance class. And yeah, I'm fine with using T3 micro. I think that's what the automatic one was in the past. All right, and then we will go ahead and let's do our username, which is going to be Postgres. Let's do our password, which is going to be Postgres. Now, you're not going to want to commit this, right? Because if we commit this to GitHub, then you're going to have your username and password for your deployed instance. All right, I'm just going to show you this right now, how to easily set it up, and then we'll go ahead and refactor. But just wanted to let you know, don't just write your username and password and then push to GitHub. The only time I would do something like this is if you're testing something out and you're planning to refactor immediately after. All right. I just want to test that it works before I start like adding variables and such. All right. So then we will have skip final snapshot true. I like that. All right. So this is good, but you'll remember when we were manually setting up our AWS or RDS instance that there were some spots where we had to add like what's the VPC, and there was spots for security group too, right? So we'll have to do that, all right? We have to provision the RDS resource instance in a VPC network, all right? And so the way that we do that is by creating a subnet group for our RDS instance, all right? So I'm gonna add this above just because for me, it makes more sense in my brain. And I'm gonna say resource AWS DB subnet group. And I'm fine with naming it that. That's fine. I could definitely get better at my names. All right. Yep. So we'll have our app name, which is coding with Callie, and then we'll have DB subnet group. That's fine. And then, yep, what we want to do then is we want to say what our subnet IDs are that we're pulling from. And so that's going to be our module.bpc and then .private subnet IDs because we want our database to be in the private subnet. All right, so this is kind of a little bit foggy of a concept to me, so I'm going to go ahead and have Copilot explain exactly what is happening with this resource just to make me feel a little bit better about what's going on. All right, let's pull it open. All right, this is defining a new database subgroup named Coding with Callie DB subnet group. A database subnet group is a collection of subnets that you can designate for your databases. The subnet IDs line is specifying the subnets that are part of this database subnet group. It's referencing the IDs of the private subnets. In summary, this code is creating a database subnet group with a specific name and associating certain privates. All right, so that makes sense. We are creating a subnet group. We're using our Coding with Callie VPC private subnets to create the group, and then we are creating the database instance. But what we need to do is we need to add the database subnet group name is going to be AWS DB subnet group to refer to this, then .db subnet group .name. All right. Let me look at the code though in the article to make sure. All right, so that's what they have. All right, so that's good so far. So the next thing that we need to do is they're creating backups, but see what we have here is we have our security group IDs, and that's what we need to create next. All right, so what I'm going to do then is create a security group. Is this what where's their security group? Maybe that's outside the context of this article. All right, well, regardless, we need to have a security group for our database. So basically, the security group is going to define what ingress we are allowed to have, okay? Because what we want is we want to be able to have our private subnets, our private instances, which are in our private subnets, communicate with our database because that's where our application lives, is in the private subnets. That's where our backend lives, which we only have a backend right now. All right. So what we need to do then is we need to create this database security group. All right. So that's going to be AWS security group. And then we will call this DB security group. All right. And then, yeah, we can go ahead and have the name coding with Kali database security group. Description is fine. I'm going to change it though, so it's a little bit more clear. And I'm going to say database security group. All right. And then, yeah, it's going to be in our VPC. Let's go ahead and add a tag with the name to it. So that way we have the name of the security group in there too, because I don't exactly remember when, like where the name is pulled from. And I want to make sure it's clear when I'm looking through my console if I need to debug what I'm looking at. So now we have the security group. Now we need to define a security group ingress rule. Perfect. Thank you, Copilot. And let's take a look at this. Okay, so we are attaching this ingress rule to our AWS security group -db security group -id. That makes sense. All right, and I don't think I need this because I think that's when we had an issue before when we were defining the CIDR block and the from ports. But so basically we want the port to be 5432 because that's what our Postgres database runs on. So we're saying that traffic can come in from 5432, okay? And the IP protocol is going to be TCP. All right, so before when we had that CIDR block, it's going to say what the CIDR block we want in, but I'm going to use our security group ID instead. So, yep, what I want is I want to say that we can allow traffic on port 5432 from any of our private instances. And so it's going to allow any instance with the security group, private security group, which is our 2 private instances, which is where our 2 servers are running to access the database. So basically, our NestJS app is allowed to contact our database. And that's perfect. And that is what we need. All right. So we should be good in terms of everything that we needed provisioned should hopefully be provisioned here. So I'm going to go ahead and Terraform apply. All right. And now I'm going to say yes. I'm going to go ahead and open up my AWS console so I can take a look once this is up and running. And I will go over to RDS. All right. You can see that it is creating. I probably should have added a name to my database instance because this kind of looks terrible, but such is life. So I went ahead and applied what we just wrote in Terraform, and then I ran my GitHub Actions, and I failed. And then I went into the Sessions Manager to look into each of my instances, and I did a bunch of debugging. I went into RDS, and it was about a 10-minute video of me not knowing what was going on until I realized that I, in the last video, had not included this line, okay? So I'd left out VPC security group IDs, which is going to take an array of IDs, all right? So when we create our database instance, we need to add the security group to it. So even though we defined the security group, we defined the security group and ingress rule here. We had never applied it to our instance, which meant that when I applied my Terraform and I provisioned all my resources, my EC2 instances were not able to connect to the database, which means that we timed out and failed the GitHub workflow. It was not a great video in terms of like, you didn't really glean anything from debugging because the only thing that was wrong was this lack of a line. So I'm going to go ahead and apply now. Make sure you add that line in, and then we will give it a try with GitHub All right, so I'm going to type in Terraform apply. I'm going to type in yes, and then I will pause this video here while it applies and resume in a minute. Just wanted to check in. Still creating. I will check in again once it finishes. All right, so we went ahead and added all of our resources. Now we need to edit our GitHub environment variables and secrets, which I think we just have secrets, in order to reflect our new resources. All right, so let's start with database host. And you can see that 4 hours ago, I did, in fact, try to do this, and that is when I failed. All right, so we're going to go to RDS, database instances, click on that and get the endpoint, and go over here and sub it up. Say nope, use passkey. There we go. All right, the password and username should be the same. So let's go and find our EC2 instance IDs. All right, let's start with 1. Edit it. Now, when you actually are deploying an application, all of this, you're not going to be Terraform applying and destroying constantly. So you won't have to change most of these details unless you're doing it for practice like we are, and then you will. But typically, you would have the same EC2 instance up if you're deploying to EC2. So that way you don't have a lot of downtime. Oh, did I just change instance 1? This is what happens when you are talking and doing something. Let's try again. All right. And this one. And change it here. All right. So perfect. Now, we didn't change anything with our code. So what we should be able to do is we should be able to just go to our last GitHub run and then say rerun all jobs. And this will rebuild the Docker image. And the reason why we need to build it again is because we just created a new ECR and having our new repository, we don't have any images in it. Okay, so go ahead and click rerun jobs. And I will pause it while it goes through this. All right, so now we are deploying to EC2. So I'll go ahead and open this up. We're running the command. Hopefully it's going to work. I still need to separate these commands into different steps so we can get a little bit more visibility in what's happening. Maybe we'll do that in the next video. But let's get this working first. All right. It's taking a while, but you know what? I think it's taking a while because the database migration is hopefully happening. So what I'm going to do is I'm going to go into our instance. Let's pick instance 1. The reason why I pick instance 1 is because we have this wait command happening where we have it for an instance 1. What we would want to do is actually have that wait command for both instances. That would allow us to have a little bit more accurate errors come up, because what can happen sometimes is you wait for the command to be done being run on instance 1, but it's not done on instance 2 yet. So then you'll get like the status is in progress, which is not equal to success. So it'll say it failed, even though it actually didn't. All right, so we failed, which could be a fail, could be not. Let's go ahead and take a look. So we're going to say docker ps-a, and you see that we have the container, and so far it's still up. All right, so let's go ahead and say Docker logs API. And to me, this looks pretty good because you can see in our logs that first it's going to run the migration. It then runs the migration where it creates a to-do table, and it creates, it creates a migrations table, and then it inserts the migration into it. Then it starts our server. So if we go and look, we say curl localhost at port 3000. You can see it says hello world, attempt to deploy a change. All right, so let's go then to our second instance here, and let's connect. And then we're going to do the same thing. Maybe we can just start out with curl localhost 3000 because we're feeling confident, and we get hello world, attempt to deploy a change. All right. So what I want to do next, because this worked, yay us. So to clarify, make sure you add the VPC security group IDs to the database instance, or else you're going to get a timeout error in your, well, not in your GitHub Actions, but you'll get a timeout error in here. Okay. And we don't want that. All right. So make sure you add that. That should get you this. The next thing that we're going to do in the next video is we're going to actually start refactoring a little bit, because it says that it's time for us to get a new job, but honestly, we did pretty great. So we're going to refactor our GitHub Actions a little bit to make it less prone to erroring when we didn't actually err. All right, so I want to refactor this a little bit because right now we just have this one step. All right, and then, or well, we have multiple steps, but we have this one step for deploy to EC2. So what I want to do instead is I want to separate this into one, then two, and then three steps. All right. So the first thing I'm going to do for this first step here is I'm going to say send. All right, I'm going to focus on what I'm doing. So I'm going to say whole Docker image image from ECR and run. Maybe I'll say pull and run Docker image from ECR. All right, so that'll be good. And then I will come here and I will say name, wait for Docker commands to complete. All right, so, and then we will add this run and then add a little pipe so we can do most of them. So now the thing is, between steps, all right, we can't really pass this command ID variable from this step to this step. Or can we? I mean, I don't think we can, but honestly, might as well. So let's go ahead and say echo, and then let's say command ID. All right, so now that we have this, what I'm going to do is I am going to comment out the build, because we don't need to build right now. Then I'm going to comment out the needs build. And then I'm going to go ahead and do git status, git add, git commit, and say started refactoring steps. And then let's push, and because build's commented out, we should skip right ahead to the deploy, which is gonna fail regardless, because we don't have our stop in there, or dash remove in there. But I'm curious as to if it will echo out. Okay, so see how that passed a lot quicker? All right, so we have yeah, expected. So AWS error argument dash command ID expected one argument. So basically we didn't pass anything into there. Okay, so what we need to do then is we have the command ID that's up here. So we have to put it into our GitHub environment variables. So we will say that we want to echo, and then we want to say command underscore ID. And then we're going to say, yep, is equal to command ID. And then, yep, thank you, GitHub Copilot. So what is this doing? So basically, actually, let's just have Copilot explain it, because it can probably explain it better than me. All right, so yep, it's appending a new environment variable to the GitHub env file. So let's break it down. GitHub Copilot. Echo is the command line utility available in most Unix-like operating systems. It's used to output the strings that's being passed as arguments. In this case, it's being used to create a string that defines an environment variable. All right. The command ID is equal to $command ID. This is the string that the echo is outputting. It's defining an environment variable named command underscore ID and setting its value equal to the command ID variable from up here. The $command ID variable is a variable substitution. It means that will be replaced with the actual variable value of command underscore ID when this line is executed. Perfect. This caret, sideways caret, sideways caret, all right, is the redirection operator. In this context, it's used to append the output of the command on its left, the echo command, to the file on the right, which is going to be this GitHub end. This is a special file provided to you by GitHub Actions. When you write to this file, you'll create or modify environment variables that will be available to all subsequent steps. So basically, we want this command ID to be available to our next step. All right, and the way that we can do that is by outputting it into this env file. So similar to how you have an env file in your folders, you have it set up as like a key value pair. All right. So the way that we would reference it here is not by just command ID. We would reference it by saying, yep, thank you, GitHub Copilot, but env.command ID. All right, so we can go ahead and echo that before the command starts. And then any place we use it, which would be here, we want to replace with the env command underscore ID. And then, all right, so we should then be able to make a new step. So check command status, run, and then we should be able to get the status, all right? And then instead of command ID here, we will use the same end command ID but we don't need to echo it again because it's already in our env file. All right, we're going to go get our status details. I'll put them into text. Status is success. Say, yay, we did it. Otherwise, command failed. All right, so this looks better. All right, so let's go ahead and give this a try. Oh, and you know what we need to do? Instead of run -d, we want to do run and then add the remove flag back in. So then over here, what I need to do, it's been too long. All right, so yeah, let's go ahead and connect because we need to get rid of the container that we already have. So see, 5 hours ago, we had that container. It exited 4 minutes ago because we stopped it, but we didn't remove it. So we want to say Docker remove API. That removed it. Now that we added back the flag, we should not have to do that again. So Docker ps-a, nothing. All right, now let's go to our first instance. Let's click connect. And then we're going to do the same thing. Let's go ahead and look first at what the status is. It should be stopped 4 minutes ago. Perfect. And then we should be able to say Docker remove API and then Docker ps-a, and we are all good. So I'll clear terminal. All right. Now we're going to say git status. We already did. Git add, git commit, finished, separating out GitHub workflow steps, and added back in remove container flag. All right, and then we will push this up. And pushing it up, we'll go ahead and trigger a new action to run, but just the deploy. So let's go ahead and open this up and take a look at what's happening. So you can see the run went ahead and ran. Oh, see, echo, we echoed the command ID, then we checked the status and put out, yay, we did it, which is exciting, and then we cleaned it up. So this just gives us a little bit more information about what we're doing. So now if I do Docker PS, you see that's running. Let's go ahead and look at the logs, Docker logs API. See there's no migrations pending, and that's perfect because we already did the database migration. Let's look at the other one, Docker PS. And then let's go ahead and Docker logs. Yeah. All right. So this is nice, but I still think we can make it one step better. And what we can do is we can wait for each instance. So let's do on instance 1. All right. And then let's go ahead and copy that. And let's add this in. We want to change this to instance 2. Because there is the time, there's like the if something's happening at instance 1, but for some reason instance 2 is taking longer, you can end up getting like mismatched statuses. So when we go to check status, it could say that we're in progress still. All right. So let's go ahead and push that up. Actually, I'm going to change something in my Docker build. So we're actually going to pull and restart. So let's go to the controller. Let's go to the service. And then we're going to say, hello world. We have a database. All right. Let's do get status, get add, get commit, except not yet. We can still commit it. That's fine. No, that's not. Okay. The reason why I'm saying no, that's not, is because I want to go ahead and comment back in the build because we changed something in our files and I just want to run the whole thing through. All right, so get status, get add, get commit, made a small change to API, and commented back in the build job. And then let's go ahead and push, and that should run the build and the deploy, and we should see all of our steps. So I'm going to go ahead and pause this video here while it's doing its thing, and then we can see how it went. All right, so now we are in our deploy to EC2 stage. So let's go ahead and look. So we're waiting for the Docker commands to complete in instance 1. I'm guessing that that step will take longer because we're waiting for instance 1, the commands to complete on there, but it's not that like the commands haven't started on instance 2. So my guess is that as soon as it's done with this step, it's going to breeze past this step here, which hopefully we're not messing anything up and everything's going to work. All right, so yeah, see how quick waiting for instance 2 took? So yay, that was really good. Okay, so now let's go ahead and take a look. Let's do curl localhost at port 3000. Hello world, we have a database. Let's do the same thing over here. Curl localhost at port 3000. Yay, awesome. All right, so now let's go grab our load balancer. DNS name, let's check to make sure that our target group instances are healthy, and we do have healthy instances. So what we can do then is we can take the DNS name for our load balancer and we can switch it out with this one. And let's go ahead and first let's start with just a GET request. Nothing, and that makes sense because I created a new database today. But let's go ahead and post to perfect. Yay. All right, what if we do, I think, is it put? Let's change this to true. Did I make it put? Nope. I probably made it patch. Patch. Use. I think I'm supposed to actually do the ID. What am I supposed to do? This actually does not matter too, but all right. So to-dos controller. All right. So slash to-dos update. We're sending the ID and the to-do DTO. So description done. So that is actually going to look like this. Let me say ID 1. And then, what is it, to do? And then these have to be in quotes. All right, now let's try, and then let's look at put. Okay, so we want put. All right, perfect. So ID 1 has now been edited to 3 and true. So let's actually edit that back to ID 1 should be to do 1. Perfect. All right, that looks great. So what did we do? We went ahead and simplified, and well, I don't know if we simplified it, but we refactored our GitHub Actions to be on multiple steps, so we have more visibility into what step went wrong. This also allows us to kind of echo out some more information. We also added a wait for on our instance too, so that way we are for sure done with all of the commands before we check the command status. All right. So now what we want to do is we want to go ahead and make a change to our to-do table because we want to try to run another migration and see how things go. All right. So we are going to work on that, and we'll work on it a little bit locally before we make the changes in the cloud. So I'm going to go ahead and just kind of get out of everything. I like to start a new task with like a clean so we have to-dos entity here, and then we have this create date column. So originally I was planning on adding this, but I accidentally copied my code over from my other repo and left it. So I think what we're going to do is we're actually going to just delete this column. Okay. So we're making a change to our database table. Now, if we in data source had this synchronized to false, as soon as we saved the okay, I actually don't think I like that because that doesn't really show what I'm talking about. So basically, as soon as we saved this, it would synchronize with our database we're connected to, which is the local one, and it would delete that column and delete all of the data with it. But also, that's technically what we would want the migration to do too. So what I'm going to do is I'm going to add a column instead, and then the migration will run that. Okay? So what kind of column do we want? Well, we want a column that nullable is true. So that's good. And then I don't want an updated at. What's something else with a to do? Maybe a title. Yeah, let's just do title. All right. And I know it doesn't really matter the order of things, but technically when I'm reading this file later, I'd want the title up here. So the reason why we have this nullable true up here is because currently, let's go look at our PG admin. Let's refresh it. Currently, we have 4 to-dos in our to-do table. So if I add a column for title into my to-do, and these 4 rows wouldn't have anything in that spot, in that column. And so when you try that, it's going to be like, no, I can't make this because I can't have a null value. I can't have nothing in that cell. All right. But if I say that, okay, hey, it's okay for the column to be nullable true, go for it. All right. So the next thing I'm also going to change, I'm going to take this nullable true away from the create date column because type ORM actually does this behind the scenes. So we have this from the beginning of our project, so it's not like we're adding it. And then B, even if we did add it later, type ORM is doing this behind the scenes, so type ORM would still know what time we added that and just add those stamps, okay? So we added our column to the entity, and now what we want to do is, all right, that's where I was running Docker, so I'll leave that open. We want to run our migration. Okay, so we're going to head to our package JSON and we're going to see the migration generate, and that's the first step to doing it. So we want to say npm run migration generate. But before we click enter, we want to go ahead and change the name of the migration. We're changing it to edit to-dos table. Then I can generate my migration. So I see that my migration has been created successfully. I'm sorry, I don't know why I can't speak today. So if I go and look at this edit to-dos, you can see that here are the SQL commands that it's going to do. So it's altering the column created at, so that way it's not allowed to be null. And then we're editing a title, okay? And saying character varying, which I'm guessing is what our nullable true corresponds to, okay? So just to drive this point home, okay? If I refresh this table, you can see that this was not automatically added, okay? If I had this synchronized set to true, it would be automatically added as soon as I save. You're welcome to play around with it on your own, but I'm not because I don't want to have to go delete the column and stuff. Okay, so now I can say npm run migration. I think it's migration:run. Yes. And so now if I click enter, it's going to alter my table. If I go and look in PG admin, you can see that now I have a title column and it's null for all of these things. Okay. So that is good. Next, what we want to do is we want to look at those commands worked locally. So I think we can go ahead and give it a try in the cloud. We could run the container now, but that's not going to really do anything because we already did the migration. So it'll just run the container, but that's not really that big of a deal. Okay, so now that we did that, let's take a look at our Docker, not our Dockerfile, our main.yaml. I guess our Dockerfile too. Let's just make sure. Okay, so yeah, the commands in the Dockerfile. So you can see that here it's going to run npm run migration run, and then it's going to start prod. So let's just make sure we look at those commands. All right, so it's going to look at source, data source.ts for all the information. It's going to then find where the migrations are and look, yep, we do have our migration. Edit to-dos is now in that. So when I commit this and it runs the migrations, it's going to go look for new migrations and then hopefully run them. All right, so let's give this a try. Git status, git add, git commit, edited to-dos table, and generated a migration. Let's push it up and let's see what happened. I can close this out. Go over here, make this a little larger. And then let's go ahead and look at our Actions tab. All right, so we're currently building. I'll go ahead and pause this video and then come back when it's done building. All right, so we went through our build stage. Now we are waiting for the Docker commands to be complete on instance 1. And that should take a little bit, but hopefully then when instance 2 comes around, that'll be quick and we'll be wrapping it up. I feel like I always struggle too. I almost want to make my screen smaller and then pull my systems managers over so that way I can kind of start playing around with the instances, but I'm going to just be patient. I'm going to let GitHub Actions do its thing. And yay, it says we did it. So let's go ahead and take a look. All right, hello world, we have a database. Let's go ahead and clear. Then let's say Docker logs API. And you can see, well, this is certainly interesting. It says no migrations are pending. But we should have run a migration. Let's see in this one. So Docker, let's just start with Docker PS. All right, up 52 seconds. So let's look at Docker logs API. Oh, okay. Duh, I'm being a dummy. Okay, so the migration doesn't happen on both instances. So it looks like this instance, right, 687. Let's go find 687. All right, so instance 1 is the first one that the command got ran on. So this is where the migration happened. All right, so one migration was already loaded into the database, two migrations were found, and so then it's going to, one migration must be executed. So it executes it. Instance 1 is what executes the migration. When it runs the command in instance 2, well, there's no migrations to do because it already did it in instance 1. Okay? So to verify that this worked properly, let's go ahead and get our to-dos. Whoop, whoop. And you can see that now title is in each of the to-dos. Okay? I'm curious if my code works because we didn't actually test the code. Let's go to put. All right, we'll change that one, and then let's go ahead and add a field for title. This is the title. And then let's send it, and let's go ahead and look. Okay, so it looks like it is editing fine. Let's do one where let's just go ahead and edit all of them so they have titles now. 2. All right, let's do 3. I'm just being silly now. Do we only have 3? All right, perfect. Now we have our to-dos. All right. So this is pretty cool, but if you've noticed, we're using PG admin to verify things and to look into stuff and to refresh. And the PG admin tool is really helpful when we're developing locally. So in the next video, we're going to try to figure out how can we use PG admin with RDS. See you in the next one. All right, so let's first try to just connect our database to pgadmin. All right, so the way that you would do it is you would go to servers, you would say register server here, and then let's say something like coding with Callie, AWS, which is RDS, okay? Then you would click over to connection and you would put your host name. All right, easy enough, we have a host name. Let's go to services RDS. Let's go to database instance. Click this endpoint, right? That's our host endpoint. 5432 Postgres, username Postgres, password Postgres. Let's click save. All right, so it's saving, it's trying to connect, and make your guesses now. Will it work? Will it not? Ah, and it will not because it timed out. All right, so you have to remember that our database has specific rules for who can connect with it. The rule that we have in place is that it is a private instance, and the only things that can connect it to it are our EC2 instance 1 and EC2 instance 2. All right, so if you remember back, way back when, to the original weeks when we used a Bastion host, this is a perfect time for a Bastion host. So what we would use a Bastion host for is we would tunnel through the Bastion host to our database, all right? And we would basically use our Bastion host to forward the traffic, and then we could connect as if we're connecting to localhost. All right, I'll walk you through how it works. Full disclosure, I did not try this before. I'm going to do it now, but we're going to give it a try. All right, see if I can remember too how we create a Bastion host. All right, so let's go ahead and let's go to, our Terraform. All right, I am going to do some copying and pasting, and hopefully we don't mess things up too much. All right, so let's find I'm just gonna make this big. All right, so here is our private instance. All right, we don't have, so I'm just gonna copy this, and I'm gonna go down to the bottom so I don't get confused as to what one I'm editing. And then I'm gonna call this my Bastion. Sure, I'll call it my Bastion host. I just want one, so I'm gonna get rid of that. I can use this AMI. The instance type will say is fine. The subnet ID, we'll go ahead and put this in our private or our public subnet, and we can just put it in the first one. That's fine. Associate public IP address. We can go ahead and say true. And VPC security group, we're going to have to create a new security group for this guy. So I'm going to go ahead and empty this array here. IAM instance profile. All right, let's go ahead and look at what this instance profile is doing. I already forgot. This is also a good reason to kind of, so this is us being able to SSM and contact the registry. Okay, so we do want to SSM. So we're going to keep that. All right, user data, we do not need Docker. So we can go ahead and do that. And then we will call this var.appName. And then we're going to call this like coding with Callie. We already have coding with Callie, so we're going to call it Bastion host. All right. That looks good. So what I'm debating on here is putting this in a private subnet, because technically if we SSM into it, we can SSM into a private instance. So we don't really need the Bastion host to be in the public, because all we want to do is I'm thinking we could reuse some of our security groups a little bit better. I say let's go ahead and try it, because why not, right? So let's do module, because we're testing things out. Okay. Back to false. All right, let's go look at what that private security group does. All right, that's a load balancer. Okay. So the private security group has 2 ingress rules, 1 allowing traffic from LB and 2 allowing all egress traffic. So really what we could do is create a security group that just has this egress rule. So let's give that a try. So all right, so we would do a new security group. Bastion security group. We'll put this as Bastion. We'll say this is Bastion VPC, and then tag it with Bastion. All right. So then let's go to our egress rule. I'm curious, can we change the security group IDs? No. Okay. So then we're going to add this here, and then allow all traffic Bastion, and then this will tie to the Bastion security group ID. All right. So then also we want our DB instance to be able to be contacted by the Bastion host. All right, I'm going to try this, and I'm going to Terraform apply it, and we're just going to see what happens. All right. So 3 to add, adding the egress, adding the security group, adding the Bastion host, and adding the security to the RDS. All right, so we'll go ahead and say sure on that one. And then in the meantime, we want to do SSM, say like forward to remote host. And let's try to all right, so yep, this is exactly what we want to do. So we want a local host on our computer, and then we want to use session forwarding to forward to a port on a remote host through an SSM managed instance. So you may ask, why can't we use one of our private application instances since we basically copied them? And my answer would be, I think it's just cleaner to like have everything have its purpose. If you're worrying about costs, you could just you could stop the Bastion host instance when you're not using it because you're only using the Bastion host for admin purposes. Okay. But I think it's just cleaner that you kind of don't get into a machine you don't need to and mess around with things. All right, so this is to start. So right, this is the command that we use to just like start the session with specific to the host. This is going to be what we'll use to forward traffic. Okay. So we're initiating a connection forwarding session to a remote database server. All right. So we're starting a session. The target is going to be our Bastion host. Okay. And then we're using the document name AWS start port forwarding session remote host. So the port number is going to be 5432, right? Because that's the port number that our RDS Postgres database is running on. Our local port number, we can make up anything, right? So here they're using 1053, but we can choose a different port. I always just add a 3 before it, and I use like 35432. All right. And then the host name is going to be the remote database host name. Okay. All right. So before we try to use that command, let's go and take a look at how things are going. So the first thing I'm going to do is look at the Bastion host in EC2. And we got our Bastion host. It is running. It looks like it's initializing still, but that's okay. All right. And yay, we have our connection here. All right. So the next thing that we will do is we will take a look at the RDS instance to see that it can be contacted from our Bastion host by looking at the security groups. And this is definitely interesting. All right, so we didn't add any inbound rules for the security group, so it's not liking that. I'm going to go compare this then with my private security group. All right, let's so I don't know why I added this. That was very silly of me. I get security groups wrong every single time. Okay, so I was adding a list, but what we need to do is we need to add another ingress rule for our Bastion host. So allow TCP traffic DB private, and then let's do Bastion. And then we'll keep all of that the same, but we'll do Bastion instead here. All right, so in case that wasn't clear, basically what is happening here in this array is that we're saying what the security group that is associated with this database instance is, and that security group is the database security group. Okay, so what we want to do is we want to make sure we have an ingress rule for our private instances, which is this one, and then we have an ingress rule for our Bastion host, which is this one. Okay, so I'm going to Terraform apply. Checking the load balance or the security group in the console is a really great way to debug because you can actually see what your Terraform code like ended up looking like and what it ended up corresponding to, and then you can identify where some of the issues are. So I always think of like, okay, inbound, what do I want to be able to talk to this whatever I'm looking at, and so on. And so I would kind of go and look, okay, so like for RDS, I want our private security, my private instances, and I want the Bastion host, so it should look like that. Okay, I'm gonna go ahead and pause this until it's done modifying. All right, so I got two issues here. So let's go ahead and try to update these two issues so that way we can fix them. Okay, so the first issue that we have here is that our ingress rule for our security group is that we already have a security, like a rule allowing for access on port 432. All right. So I think creating the duplicate ingress rule is maybe not the correct thing. So I'm going to ask Copilot to help me with that. The next one is VPC based instances require at least one security group. So we created the Bastion host instance, but then never put the security group with it. So we can go ahead and add this here, AWS security group Bastion security ID. So that will go ahead and fix that part. The next thing that I want to do is I'm going to highlight this and I'm going to go to Copilot and I'm going to say, how could I edit this so ingress is allowed from multiple security groups? And let's just see what Copilot comes up with. Hmm. But see, that is what I did. Let's compare. All right, so now the next thing I'm going to do is I'm going to say, explain this error. So it says it already exists and we're trying to create it again on 187. I mean, this one I agree does already exist. Let me just try to Terraform apply. I think I might have messed up my Terraform, which is life. So security group ID, database security ID, private. Oh, because I changed the name of it. I think it's because I changed the name of it, but technically like these things already exist. Let's see. It says it applied that time, so let's see how it did. All right, so I'm going to go back to my RDS and I'm going to take a look. All right. So it looks like I have two inbounds. All right. Same security group. Let's go ahead and look at that security group a little bit further. Let's look at the inbound rules. So it looks like we can access from the Bastion host on port 5432 and from the private security group. So that's awesome. That looks good so far. All right. So now we are going to go ahead and try this magic command. This video is getting long, so if it doesn't work, I'll go ahead and add a command in another. I'll add my debugging in another one. So you could put this in like a note page and then in a notepad page and then fix it. But I'm going to just go ahead and delete everything that needs to be changed. And then I will go ahead and fix everything. All right. So we'll start with the target, which is going to be our EC2 instance. It's going to be our Bastion host. All right. So let's paste that in there. All right. Then we need to put in our port numbers. So let's go ahead and do that. So the port number on RDS is 5432. And then our local port number that we're going to use instead is 35432. And then the host that we are trying to forward to is going to be this endpoint. And all right, well, that's a good sign. So it says that we're starting the session. All right, port 3532 is open. Okay, so what does this mean? This means that locally on my computer, I have, right, local port number 35432 is open to connect to. Okay, so when I connect to 35432 locally on my computer, it will then forward anything I do to my RDS instance in the cloud. So instead here, we can put localhost or 0.27.0.0.1. And then we want to do 35432, Postgres. Now we save, and you can see it says connection accepted. So that is a good sign. And now you can see that we have our coding with Kali RDS instance. You look at database, Postgres, schema. Let's just make this big. Tables. Now you can see we have our migrations table and then our to-do table, which is what we are most interested in. And you can see that this is the title. Okay. If I go back to my Postman and let's say I want to post a new to-do, so I can do something like this, and I can say like new to-do, and then we'll call this to-do 4, and we will say that this is not done. And we send it. Now you can see that we have a 4th to-do. You could go to your table over here, and we have a 4th to-do as well. All right, so that is how you would connect through a Bastion host. That was hopefully not too terrible of an exercise watching me flail through that. But I'm going to go ahead and destroy everything, and that is going to wrap up this week's challenge. Okay, so to just summarize, we added an RDS instance to our architecture. We also added a Bastion host. We used the Bastion host just for admin purposes in order to forward traffic to our private RDS instance. We edited our GitHub Actions to make our jobs a little bit clearer to understand and debug. And yeah, we figured out database migrations. It was a pretty intense week. So I would recommend doing some extra reading, testing out some of the things that we did, speed running some of the challenges, and yeah, hope you had fun. See you next week. I apologize in advance if the audio is bad for this video. I forgot to make this video, which should tell you that if you say you're going to do something in the future, you should just do it then and not put it into tech debt. But anywho, I digress. I don't have my microphone because I'm sitting on my couch recording this, but I felt like I couldn't go to sleep without showing you how to protect sensitive input variables. Okay, so when we created our RDS database, right, we just hard coded our username and password, which you don't want to push to GitHub, not good. Okay, so I found this tutorial, which I will bookmark and then add to the challenge, about how you can protect your sensitive variables. So I just figured I would go through it and kind of copy how we do it. So they're using an example repo. Okay. So first we're going to refactor the database credentials. All right. So it looks like what they're doing is that they have a var variables.tf file. So that's where they're going to define it. So I have a variable, apparently variables.tf file, and I'm going to add it to that file. So I'm going to have variable db username and type string description. And I'm not going to have a default, but I'm going to instead write sensitive true. All right, I'm going to copy this, and I'm going to have the same thing, but now I'm going to have for db password. All right, following this. So basically what this is doing is now like Terraform won't output anything marked with sensitive. All right. So now we need to change the way we're referencing things. So instead of hard coding Postgres here, we would use var.db username, and then var.db password, right? But we didn't set anything equal to those there. So that's not super helpful of us. All right. So see, if we ran Terraform apply, let's actually just show you. So I run Terraform apply, and it's going to ask me for my password. And then if I type in a password, it's going to ask me for my username, okay? Because I don't actually have a value in there. So you could do that. I think that would be one way that you could do it. But a better way, or a maybe more automated way, would be to add a secret.tfvars file. All right. So we'll assign the values here. All right, apply these changes using the -var file parameter. Because you flagged the new variable as sensitive, Terraform will redact their value in its output and mark it a sensitive value. Okay? All right, here's just some other stuff. So let's just go ahead and try to give this a try. So basically, this is like you're saying Terraform apply, and then you're passing in that your variables are going to be from this secret TFR. So if you think of Terraform apply like you're calling the apply function, then this would be like your parameters that you're passing in, or your arguments. I always get arguments and parameters confused. Okay, so let's do db underscore username, and it's going to be Postgres. And then db underscore password is also going to be Postgres. And then you would just make sure that in your git ignore, you have all tf ignore variable files. I would check that by doing like a git status, and then you could see if so secret.tfvars did get put in the status. So you would want to make sure it doesn't. So maybe I would do like all/tfvars. Let's see if that works. All right, and that removed it. So now Git won't notice my secret file. So now my secret file is good. So if I were to just do Terraform apply, it's still going to prompt me, right? Because I didn't say where to look for these values. But if I do Terraform apply and then I do -var -file equals secret.tfvars, then it's going to just say, oh, now we can do it. I'm going to say no because I'm actually not going to apply those. But that is one way to kind of make sure that you're not pushing your secrets to GitHub. Now, there's lots of other things we could do for secret management that's kind of outside the scope of at least this week because we're over time. But coming up with a hard-coded password is probably not the best. You might want to randomly generate one. You could also use Session Manager to store your secret, or Secrets Manager to store your secret in AWS. Hopefully we get to that in another week. But anywho, at least this won't commit your password. All right, see ya in the next challenge. For real this time.